My name is Jason Beim, everybody. I am a FAA Fast Team Drone Pro representative. I represent, I guess I can't use the word represent, I volunteer for the Allentown FSDO over in Pennsylvania. Represent basically the drone community. We interact, collaborate with the FAA. We do all types of things, primarily outreach. If there's issues out in the field, possibly violations that occur, what the FAA will do is have me reach out to you. We can do some type of counseling to make sure we're all on the same page, you understand expectations, and move forward. So if anything, look at me as a peer. Again, I do not work for the FAA. I do not fully represent the FAA. I more so volunteer. I am an advocate for drones and UAS. So that's what we're going to get into tonight. So again, welcome. Thank you, everybody, for joining us tonight. We are excited to be hosting one of our first Fast Team webinars. Typically, these are reserved for in-person format. So we'll go to a local FBO or a local an airport, an area of a smaller general aviation type of airport, do more of an in-person type of engagement. However, the luxury of doing it via webinar is you get to be in the comfort of your homes. You don't have to come out, and we can deliver to a much wider audience. So thank you. So the FAA Fast Team, if you're interested, the website is faasafety.gov. All different types of resources from presentations to trainings and etc. The Fast Team has a program called the WINGS program. Right now it caters more for manned aviators, but there is development right now for it to be introduced into our remote pilots. So as you have your certification, currently your Part 107 license or certificate, we now have the recurrency requirements. So after a certain amount of time, you'll get some more additional training to stay current with the field and the changes, and you maintain your certification. With the WINGS program, it's more incremental. So you keep up as developments happen. You come on to a delivery like this, sponsored by FAA Fast Team. You'll get credit for attending. And right now, I just want to remind everybody that there is currently no credit being given for the WINGS program with remote pilots today, but it is definitely something in the works for tomorrow. My background is I have a pretty extensive and broad background in aviation. I have an airframe and power plant mechanic license and associates in aviation technology from Penn College. I have a bachelor's degree in air traffic management with Embry-Riddle Aeronautical University in Florida, Prescott. There's also worldwide. I also have a master's degree in unmanned systems technology with a specialization of safety and small UAS. And that is basically my background in academia. So an avid UAS fan. I have served the FAA for about 17 years in the air traffic organization. I have worked in numerous facilities all around the US, from New York Center, the En route Command Center at Long Island, New York, Palm Springs Air Traffic Control Tower in California, Providence, Rhode Island Approach Control and Tower. And then I became certified at Teterboro Air Traffic Control Tower in New Jersey. From there, I transitioned my career into the management side of the house as operations supervisor and ultimately air traffic manager of Morristown during the President Trump VIP movements. Those were interesting summers. I was helping oversee an 804 project up at Wilkes-Barre Scranton Approach Control and Tower. And I finished my FAA career as an air traffic manager at Teterboro Air Traffic Control Tower. So besides the background in education and UAS and my FAA career, I currently work in the aviation sector, specializing in unmanned aircraft systems, where I oversee safety. So that is a little bit about myself. I do want to recognize Warren County Community College UAS program for having me on tonight, being sponsored by them with the FAA Fast Team. I serve as a senior adjunct professor with Warren County Community College. Phenomenal program. I noticed we have a lot of students on from the program. A ton of opportunities, excellent courses, and we try to maintain up with the changes and helping the industry expand and helping our students, land careers in aviation, in particular in UAS. So again, thank you, Warren, for having me on tonight. I look forward to getting into it. So we do hope to have some of these web series continuing forward. We like to have it on a recurring basis, very similar to what you're going to see tonight. And then we can, keep these topics and introduce more relevant topics as we move forward through the series. So this is going to be our first delivery. Do apologize if there are any technical issues. We try to iron them out a little bit earlier, and I think we're in good shape. So thank you. This presentation, a collision case study and safety discussion featuring a DJI Matrice drone for Cessna 172 in Canada in August of 2021. This will be presented to the flying public and also Warren College for the sponsoring. Again, my name is Jason Beim, and today is September 5th, 2023. We started tonight at 6:30 local Eastern time. The presentation is going to emphasize the need for both remote pilots and manned pilots to work together to share the skies. It's going to capture concepts of everything from poor ADM, CRM issues. We're going to see lack of situational awareness, everything from impulsivity, and a few other airmanship principles that, if adhered to, could have helped prevent this outcome. So very interesting. It's always good to learn and have these learning lessons based on experiences that happened. I know for myself, I try to be as proactive as I can in all facets of aviation, but sometimes the most valuable lessons learned are exactly those, the lessons learned. So drones can pose a real risk to rotor and fixed wing aircraft. Many people erroneously think that drones, they pose little to no risk to persons or property in the air and ground. There are documented collisions and near misses to prove that drones basically do pose significant risk to others. We're not free of risk when we have our drone in the sky. So again, we're going to target UAS pilots, but there's also learning lessons for our manned aviators as well. The key emphasis here is we have to share the skies. We work together as we move our industry into integration with the National Aerospace System. It's a false assumption to assume that you'll never encounter a manned aircraft below 400 feet. We have all different types of aircraft, from helicopters. We have ultralight vehicles, crop dusters, parasails, even manned balloons, etc. So a lot of activity in our National Aerospace System. Don't fall under the perception that open sky theory. If you're not familiar, that's a lot of sky, that's a lot of altitude separating aircraft. What could happen? If you fly near hospitals and helipads, if you fly near airports, you're going to see increased traffic volume. And we really want to be vigilant, especially the low-flying emergency medical service helicopters landing or departing from helipads. If you operate near crops or open fields, I know we have a lot of farmlands and agricultural areas in northwestern New Jersey, particularly in Warren County. We have to stay vigilant, look out for low-flying crop dusters. Okay, they pop up on you, which we'll talk about. We want to take extra precaution when flying near people. So drones and public safety, they're not certified by the FAA and often experience unexpected failures or loss of signal. We want to plan for the unexpected and consider risk whenever we fly. And that's why we take safety so seriously, especially in the FAA, but in our institutions, training facilities, training programs, and most importantly, ourselves. Every time you fly, you want to make sure you're prepared. You want to make sure you understand the risks associated with your flight. And you want to make sure that you're responsibly participating in the National Aerospace System. Encourage you to check out the FAA handbook. It's FAA H as in hotel -8083-2A. Yeah, that's a mouthful, but that's H-8083-2A. That goes over the risk management handbook for some of our great ideas and the FAA's great ideas on how we can manage risk. Okay. So there have been 7 confirmed collisions between drones and helicopters in the U.S. since 2017, and that's going up until about August, probably the end of September of 2021. So we can only imagine these numbers have increased since then. Since those statistics, 3 of the 7 collisions occurred below 400 feet. If you're not familiar with AGL, that's above ground level. That's how high over the actual surface of the ground it is, not going off of the sea level. So remote pilot operators, if you're not familiar, the highest they can go, free of any further restrictions like airspace, they can go up to 400 feet AGL legally. There have been at least 2 probable collisions between a drone and a small GA fixed-wing aircraft in the U.S. And there were 116 near mid-air collisions reported between a drone and a manned aircraft in the U.S. during fiscal year 2022, 66% over 2021. That's about 70 near mid-air collisions. The instances are on the rise because the number of drone operations within the national airspace system is on the rise. That's why we now have the FAA recognizing drone pros, and we're doing so much outreach these days, because we need to make sure that we're bridging any gap between formally trained aviators and certified remote pilot airmen. Okay, we use the terms basically interchangeably this time because there's a responsibility. If you have a Part 107, you're certified by the FAA, you are participating as an aviator in the national airspace system. We all have a responsibility. So today's objectives, our goal for today is going to be to increase awareness and understanding of aviation risk. We hope to get some of the pilots and whether you're manned pilots or remote pilots to make some positive changes in your operating methods. We want to lead to an decrease in the number of near mid-air collisions and just overall actual collisions. Many drone pilots perceive drone flying as being risk-free or low risk, and it's really incorrect. It's not the right perception. So hopefully, after this presentation and discussion, some of you will think a little bit differently about how you operate and how you instill safety into all your operations. So increased awareness, understanding of aviation risk, generate discussion and share best practices to reduce risk within aviation. And most importantly, we want to spread a positive safety culture. We need manned aviators, remote pilots working together. As we just discussed, 400 feet AGL really isn't that high. And there's a lot of operations happening depending on where you are. And it's just a matter of time before, I hate saying it, the next incident occurs. That's why it's so important. Learn from these lessons and don't be the next report. If you're not familiar, I'm not sure if I define the acronym. As most of us from aviation are aware, if not, you will be aware. A ton of different acronyms. An NMAC is a near mid-air collision. The terminations of what constitutes an NMAC, everything from vertical to lateral to launch, all different types of orientations from the aircraft, speeds, trajectories. There's a lot that goes into classifying what an actual NMAC is. So to get the conversation started, let's discuss an actual mid-air case that took place in Canada. Much of the information is going to be presented. It's derived in a large part from Air Transportation Safety Investigation Report, the number A210-0069, and that comes from the Transportation Safety Board of Canada. We do appreciate them making this information publicly available in the interest of safety. So this scenario could have happened in the US. We're just focusing on an event that happened in Canada. The Canadian oversight for accident investigations is going to be our equivalent to the NTSB. The Air Transportation Safety Investigation Report, it was released in the 19th of January of 2023, so it came out this year. A lot of interest in what actually went into the investigation and what came out of it. So a mid-air collision between a drone and a fixed-wing manned aircraft occurred in Canada in 2021. As I mentioned, it happened in August, and the pictures on the left are actual photos of the damage to both the aircraft involved in this collision. The picture on the right is from the visual flight rules map of the airspace in the vicinity where the collision occurred. So if you see that red X there, that marks the approximate location of the collision, and that's not the scale. According to the Canadian flight rules, a drone, it just cannot fly in this airspace without airspace authorization. So very similar to how we have the national airspace set up. Well, that's why it's so important to know what class airspace you're in and the rules that you're operating under. So imagine what might have happened if the drone had hit the propeller or the windscreen instead of the bottom cowling there. I've seen numerous bird strikes in my days when I was with air traffic control, and the damage every time, it's extensive. The aircraft, the unmanned aircraft system could have gone through the windscreen. It could have injured or killed the pilots. It could have taken off the front landing gear. It could have snapped off the propeller. That's why this is such a significant event, and that's why we're going to analyze it and break it down. I do also want to note that the airport that this happened at, this is the Toronto Buttonville Airport, Charlie Yankee Kilo Zulu Airport. It is one of the busiest airports in Canada. So the who, what, when, and the where. So at 1:01 p.m. local time, The weather was broken clouds at 2,200 feet, visibility greater than 15 miles. So that means operating in VFR conditions, visual flight rules. Break it down in a little more detail. The Cessna 172, flight instructor and student pilot. They're flying VFR. They're returning to the airport with no ATC. Radio calls were made announcing their position, and the aircraft was on final approach to landing to the southeast. They had no ADS-B out. So for those of you not familiar with ADS-B out, it is a piece of equipment that pushes a signal out so other pilots and air traffic control can see where your aircraft is, even if you're not talking to anybody over the radio, whether a flight service or a controlling entity. The ADS-B out, there was some recent developments in 2020 with the launch of ADS-B requirements. Not everybody is participating, so not everybody's going to have these signatures that get pushed out. It's also good to note that aviation, especially air traffic control, they use radar systems as well. So if they're not sending that World War II signal out, the basically premise of what radar is, they are not going to validate that that's actually an aircraft. So another reason why ADS-B out is important, especially depending on what airspace and what environments you're going to be operating around. The unmanned aircraft system involved in the event was a DJI Matrice 210. It was a one-person crew, so there was one person operating it at the time. The drone dimensions are roughly 35 inches by 35 inches by 15 inches, and it was a maximum takeoff weight of 17.5 pounds. The drone pilot was called to assist in a police operation with an armed suspect. The aircraft was airborne for about 5 minutes into the second sortie of the day, meaning the second lift or the second operation of the day, hovering for 2 minutes when impact occurred. The altitude was 400 feet AGL, and it had no anti-collision lights on. According to Canadian flight rules, all pilots are properly certified. The aircraft were properly registered. All aircraft complied with equipage at rules. The drone pilot was a police officer assigned to one of the 5 separately managed drone teams within the aviation unit, flying a government-owned drone. The Cessna was returning to its home airfield following a VFR training flight. There is a tower at the airport, but it was not in service, and it hasn't been in for years, so it was considered an untowered airport. So this was the encounter. The Cessna pilots were descending to land visually, and they did not see the drone in their path. So the drone was not using anti-collision lights. The pilot was not looking at the video feeds on the screen. They had their face basically buried in the graphical user interface, or the GUI, ground control station. The drone pilot was task saturated, did not even hear the Cessna radio calls. Untrained visual observer was asked to watch the drone, but failed to do so. That's why the FAA and the Canadian boards, they determined that it was a single crewed operation. Drone pilot and the VO did not hear the approach of the Cessna, and the collision occurred in controlled airspace at approximately, again, 400 feet AGL. So again, look at that damage. The drone grazed the prop, impacting the lower cowling. However, imagine what the outcome could have been if it had a 36-inch wide, 17-pound drone hit the propeller, went through the windscreen instead of hitting a metal cowling on the underside of the aircraft. It could have been a lot worse of an outcome. So the approximate location of the Cessna and the UAS were in the where this the midair collision occurred. You can see there on the left image, the green is the remote pilot flight path, remote pilot aircraft flight path. The Cessna collision is where the red X is. You can see where the Charlie Yankee Kilo Zulu airport is, and in relation to that, the yellow line is the extended runway center line. So the airspace authorization is required in the airspace in this particular event, in the particular environment the collision occurred. Some of the interesting findings of interest here is the drone pilot did not see and avoid the Cessna. Cessna pilot did not see and avoid the drone. So that's never good. We don't have a remote operator looking for a manned aircraft. We don't even have a manned aircraft looking for the remote aircraft. The drone control station was able to read ADS-B in, but the Cessna was not equipped with that equipment. It wasn't necessarily required to have it either. It's just, again, a tool in certain types of environments. Aircraft it's voluntary. They're not required to have it on. The drone pilot was distracted. We call this task saturated. When there's so much going on, you have to filter out some of what you determine are distractions so you can focus at the task at hand. It's never good if you get into task saturation. There's been endless safety reports from NIOSH, our firefighter type of event review process where the official reports come out. Most of the time it comes down to task saturation and communications. Monitoring airport and police operational frequencies, that's prevented the remote pilot operator from focusing on those. They were focused on best camera feed to use, and they were watching the video feed on a TV or a tablet. Most likely it was a tablet in this instance. Some more findings. The department policy for the drone pilot to fly the aircraft, simultaneously operate the camera and use any other officer as a VO when needed. That's what stood. That was their standard operating procedure. That's what they got the approval to do. The VO was assigned ad hoc and not trained. The VO was not watching the sky. The drone pilot did not follow a department checklist. The drone manufacturer's geofencing controls were disabled. No airspace authorization was requested due to urgency. Some of the similarities we see with this as we relate it to our national aerospace system is in these types of situations, it would fall under Part 91 type of operations. You need to apply, you have to be a special or a government interest, you have to have a public declaration letter, you have to have a reason for nonprofit representing basically a government entity. Once you do that, you go through a COA process or a certificate of authorization process. You have to register your aircraft, a whole bunch of sets of rules a lot of people aren't familiar with because it's pretty niche. But that allows you to deploy during emergency situations. You can get airspace authorizations pretty rapidly. You can disengage any types of geofencing that maybe a drone manufacturer like DJI may have in place. So it opens you up to a lot of freedom so you can get that aircraft in the sky as soon as possible to provide public safety support and interventions. However, we also need to realize that when we respond to a public safety event, the stakes are high. Things happen fast. We think we fall into impulsivity. We fall into cutting corners because we're so hyper-focused on our mission. We don't take a step back to breathe. We lose that situational awareness and we find ourselves in difficult positions. So whether you operate under Part 91 or Part 107, you're all going to have external factors increasing the stress of your operation. The point I want to emphasize here is we need to slow down. New drone pilots, they often focus on reducing ground risk and seeing drones as a great tool to increase safety of their drone operations. But often, the way they operate the drone can inadvertently transfer that unacceptable risk to the air. This can be particularly prevalent in public safety, as we mentioned, for all the reasons above. Increasing your awareness of air risk is one of the main goals of this presentation. Again, we go out, we do our site assessment before we go flying. We identify obstructions and hazards, anything from electromagnetic interference. We follow our checklist. We're primarily focusing and fixating on ground risk. Again, the goal here is to now have you start expanding your awareness into air risk. What can you do to minimize risk in the air? So risk controls were not followed or were bypassed. So the Swiss cheese model is often cited in accident investigations. Growing up in aviation world, I've seen the Swiss cheese model over and over and over. I thought it was initially a FAA specific campaign, but the Swiss cheese model can apply to all different types of industries and fields. It's a scientific type of representation of how the perfect storm can occur where risks, they're not caught. The Swiss cheese model is often cited in accident investigations when the holes in the safety continuum line up and an accident occurs. If any one of the risk controls has been completed, the accident would not have occurred. In this collision, a number of risk controls were in place, but were either ignored or bypassed, leading to the right conditions for an accident. So again, performing any one of these pre-established risk controls may have averted this collision. We got to think to ourselves, what do we do? How do we prevent risks? How do we prevent collisions? What are we doing to ensure safety into the national aerospace system? You start at the right of the model. I'm not sure if it's your right or my right, but we'll just call it hazards. We have different control mechanisms, different safety controls in place. Our checklists, geofencing, airspace authorizations, we maintain visual line of sight. And under the perfect conditions, when our interventions or our mitigations do not catch the hazards, that's what leads to collision. We've seen it over and over in aviation, whether it's with manned aircrafts, airline disasters, or drone collisions. So it's something we really got to start thinking about. Cutting corners is going to expose you for a collision, and that's what we're trying to reduce here. So general discussion. Dawn, I'm not sure if you can open this up for any questions or any feedback, but if we can do it, let's talk about the factors that influence collisions, not just about the particular accident. So we can do this two ways. If you want to put your thumb up, Dawn can either open the screen up, or you could throw something in the Q&A section. She can read it off. We could have a discussion that way. I don't want to spend too much time in this section here just because there's more to get through. We're about halfway through the presentation. And also, this is a first-time production, so there will be some technical constraints we'll have to work through. But Dawn, up to you if we can get some access to hear some feedback.
Sure. The Q&A button should work along the top screen. I'm working on sharing cameras.
So I'll present the question again. Let's talk about the factors that influence collisions, not just in this particular accident, right? So has anybody been in a situation, a scenario you'd like to share? Things that stand out to you that are important that may help other people avoid the risks that were inherent in your situation? And I am not sure, Dawn, do we have any takers? If not, we will just move along.
No, but I believe I did turn on the cameras and the mics. So if anybody wants to participate that way, they can jump in. There we go.
All right. Thank you, David. How's it going?
Yeah, good. Thank you for that. All right. I'm a drone operator, and I have my own company. And I think one of the factors I've observed is that sometimes when you're flying drones and unexpectedly there's a kind of wings. I have a basic understanding of aeronautics and wing patterns, but sometimes when you fly drones and you find out that the wings come from maybe from the west or from the north, depending on the pattern or the path you're going. But sometimes if you are not careful enough, you may lose the drone because of the weight of the drone and the wings, that is coming.
Absolutely, David. No, for sure.
If you are flying opposed instead of against the wings, sometimes it sways the drones away. And the second thing I found out is that sometimes, which is related to the wings, the wings turn the drones. It kind of spin the drone. So if you are not careful enough, you may not be able to bring the drone back.
David, you make excellent points there. I agree with you 100%. I think winds have to be calculated, all of weather, and thinking about the factors that influence collisions. In particular, you make good points about performance, and if you fly out a certain distance, are you going to have enough battery and power to get back to your departure point, etc. But as far as influencing collisions, the point I want to emphasize here is just weather in general. It may be hazy out. It may be cloudy out where you're just skirting VFR conditions, maybe your MVFR conditions. And we have to think about, well, we see the aircraft, what are other aircraft seeing, right? We got to think about the weather in general. So good points there. And then with the weight of the aircraft, for sure, I can tell you what, a 45-pound drone will do a lot more damage than a 0.55 ounce drone, right? But there's still collision. There's still a potential for a significant event to occur. So regardless of the weight, the factors that influence collision, I will take those. Excellent job. Thank you, David. Kathleen, it looks like you have your hand up.
Yeah, hi. I actually thought this brought up an issue that has been on my mind since I took the certification class. I'm newly licensed Part 107.
Awesome.
Thanks. And I'm continuing on with Warren Community College, because when I look at this situation and I see that one of the factors was the operator, the RPIC was not just in charge of flying the drone, but also supposed to monitor the video feed as they're looking for this individual, and then a visual observer to watch the drone. I almost feel like you need different sets of eyes. Like, I find myself right now, just as I go out and sort of play around, trying to decide, do I look at what's on my screen, or am I watching where my drone is, and how do I create a balance between those two things? I can really easily see where in a situation like this, where it is kind of intense and it is kind of high stakes, that maybe we should be looking at how many pairs of eyes do we really actually need to maintain the safety. It feels like that was a failure that happened in this setting.
No, absolutely. They're great points there, and we have to come back. There's two things. There's a lot of things happening with this, but we think about the organizational process, right? We think about what rules, procedures were in place from the organization to allow one operator to manage not only flying an aircraft and control the airspace in a busy flight path, but to then manipulate the controls and to operate the sensors, the cameras. So there's things that we have to explore in that realm. Organizationally, did they set that remote pilot up for success? Okay. Then we look into the individual factors. The remote pilot is the remote pilot. They are the one responsible for that aircraft. Was it a hazardous attitude they were confronting? You know, we know about different hazardous attitudes: impulsivity, machoism. There's 5 of them. So we need to then evaluate us ourselves as remote operators. What can we do? What are we doing to ensure our operation is safe and we're protecting other entities operating in the national airspace system? So there's a lot of things going on here. A lot of things contribute to this event, but hopefully we can kind of self-reflect here. Think about what we do individually that could influence a collision. If you're not too familiar with your software, ensuring that you become very comfortable in it, especially as you operate in more high-risk environments. We talk about things just from what I know in the industry and what's emphasized in Warren. We talk about crew resource management. Where's your team? How can you pass off some of the workload? How do you share the responsibility to use that safety into the operation? So, whether you're operating under a specific set of rules that is not necessarily regulation, but policy for your company that have been approved, or you're operating individually. 2 things we want to evaluate. But at the end of the day, it's going to come down to us. We're the last safety net. We're that last piece of cheese to prevent a collision or a significant event from occurring. So excellent points. Thank you. James, looks like you have a question or comment. So again, factors that influence collisions.
Good to see you, Jason.
You too.
All right. So I have 2 examples. There was a time where I was doing a demonstration for some firefighters of some equipment, and I was trying to show them how the drone did certain things. I was probably about 150 AGL at the time, and they wanted a demonstration of the range. So I was going out to go over some trees to show them a greater view, which was just a golf course. And the golf course was closed that day, and the park that we were flying at, we did all of our pre-checks. But I got distracted in trying to show them my screen, and I flew right into a tree. It didn't hurt anybody or anything. It damaged, the aircraft. But, I learned from that experience. So just recently I was doing an inspection of a brand new warehouse. And I got there, everything was nice and crystal clear. I had lands up to 150 feet, so I kept myself at 147 on the return to home. And I was probably about a third of the way through my photo shoot, and all of a sudden the clouds just started getting dark and gray and moving in. And by the time I came for my third round, like to the back of the building, I could tell that the drone, it was just a Mini 3 Pro, so it wasn't handling very good wind because it was so light. I just felt like it was not responding well to, you know, landing. So I was tempted to like use the, you know, hurry up and get it done. And then I just thought about it and I'm like, I don't really want to risk, one, my aircraft, and two, this thing getting blown out over the roadway and having something happen. So I had to end my mission and come back another day.
That's smart. That's exactly excellent aeronautical decision making. That's what needs to be done. You know, we don't want to hyper focus and look at the end goal. We want to think dynamically. We want to think the moment that we're in, right? We don't want to look for what's our mission, what are we trying to accomplish. We think about what is the current environment I'm operating in, and we do a little projecting here and there to, you know, anticipate obstacles and other hazards. But by making that decision, you know what, it's not worth the risk. I'm going to land it. I'm going to have the aircraft in my possession at the end of the day so I can fly again, right? So I have an aircraft to fly again. Excellent sound decision making. What you mentioned sounds like a little bit of, there was a little distraction happening in the first example. And then the second one, you understood that hazardous attitude of possibly impulsivity. You landed the aircraft and you flew another day. So thank you for that, James. Excellent. All right. Does anybody else have their hand up other than James? We can start moving along here. All right, thank you. So Dawn, if you don't mind, please, if you can remute and disable cameras, we'll just keep moving along so we don't have any unexpected interruptions. But thank you, everybody, for that, that participation. So collision avoidance in drones, the smaller the drone, the harder it is to see. The farther away the drone is, the harder to maintain visual line of sight. So we got to consider everything from color contrast, the abilities of your eyes, your ability to differentiate objects. Visual illusions are a factor in the visual line of sight. We got to think about sound waves, right? So we're moving on from the optics of an incident or optics of our physiology, and now we infuse safety as an individual. We move into things like sound. So sound waves are affected by environmental factors such as wind speed, the wind direction, density, other noise, echoing off of buildings. Why are sounds important? Because we see and avoid, and we have senses, and besides our eyes, we also have ears. Okay, drone cameras have very limited field of view. If you have your head down in your tablet and you're flying your aircraft and you're never looking up, not only is that dangerous, and it's still not necessarily legal. It's not legal under Part 107. It's dangerous because you're fixated in a very small. It's like you're looking through a map via a straw. You're looking through a straw at a map. Okay, you're not going to have that situational awareness. We want to make sure we're aware of that. Sometimes when we first start out flying, it's hard to pull ourselves out of the stream, but build that discipline. It's only going to protect you. It'll enhance that situational awareness. You'll be in that much better of a position. We want to think about trees, buildings, and terrains that obstruct one's ability to see all the airspace for other traffic. Not all manned aircraft have ADS-B out. We got to remember that, and we'll talk a little bit about that in a moment. A lot of drone pilots, they think that all manned aircraft equipped with ADS-B out, they think that that's a lifeline, that's protection. It's an incorrect assumption. Drone pilots, we cannot rely on the ground control station for picking up ADS-B signal as a primary means of collision avoidance. For those of you who do not know what I'm talking about, ADS-B, there are all different types of free databases out there that'll provide you ADS-B data. Some aircraft now, some unmanned aircraft systems will be equipped with ADS-B. Not all manned aircraft are required to participate. So don't get fixated on that. It's a trap. Pull yourself out of that. Try to see and avoid aircraft, okay? They're tools. They may enhance some of your situational awareness, but what happens is we begin to drift. We begin to think about, okay, I have this tablet here, and I can see all the aircraft around me. And next thing you know, the one aircraft that's not participating is the one that ends your day. All right. Additionally, we have drone cameras, and again, they have very limited field of view. Keep your head out of the tablet. Keep glancing up. Keep looking at the aircraft, making sure you're analyzing the horizon, you're doing your systematic scan, and you're flying safely. You have to see others in the aircraft in time to get out of the way. So the best way to do this is to watch the surrounding airspace. We want to rely on our senses, from our vision to our ears, traffic noise. We got to recognize reflected sound waves. We got to think about other factors impacting our environment. Okay, and they can provide false cues in the direction of the sound. So build that discipline. Relative size, color contrast, and backgrounds. So the Matrice 210, that's the aircraft of interest. And when I say it interchangeably, that's how I refer to unmanned aircraft systems or drones. I give them the respect of calling them aircraft because they're entrance into our national airspace system. So the Matrice 210 is the size of a red-tailed hawk. A Mavic 2 is the size of a Blue Jay and has a wingspan of less than 1 foot. Okay, the smaller the drone, the harder it is to see. The more the drone blends into the background, as viewed by other pilots, the harder it is to be detected. You don't want to count on other pilots seeing the small drone. The slower it moves, the more it doesn't behave like a bird, the harder it is for us to see, or for the other pilot to see. We need to understand the two different sides of it here. Think about yourself as a remote operator looking up to the sky. You have some contrasts, maybe a solid blue sky background. Then you have a manned pilot looking down, basically the opposite perspective. They're looking down. These small little items, these small little aircraft, these small little drones are going to blend in. They are going to be very difficult to detect for the manned pilot. How likely and how far away will another pilot see a stationary unlit black drone in the background that we have in this picture here? So there are 3 drones in this picture. I'm not sure if everyone's blowing up their screens and trying to see where they're at. I can't locate them. I think they have the black boxes that are, I see 2 of them as I go through my scan here, one of them being all the way to the right, the other being all the way to the left and slightly down. And there is somewhere in the middle. If you could see it, you got a good scan. But the point is, we cannot rely on other aircraft giving way to your drone, even though if you think it's big. You got to ask yourself, will they see in a timely and safely way where they can maneuver their aircraft away? I'm going to just take a step back here, just a personal experience. When I do go flying in manned aircraft, usually a Cessna 172, the same type of aircraft in this presentation, we have flown with ADS-B. All right, there's different apps. Some systems are certified. We have to be very careful with what data we're depending on as a valid source of truth. But what I'm getting at here is the aircraft I had was ADS-B. They had a certified system in place. We were able to see other aircraft in our vicinity. Manned aviators, will also refer to it commonly as the fish finder. There's other systems, terrain collision avoidance system, or TCAS. So other types of detection systems that are out there. Personal experiences, when I went flying, we had ADS-B. We saw other aircraft in our vicinity at similar altitudes, and it's always a battle to scan and find them. And then you see them because they're big. But there's constantly, under VFR conditions, we're scanning our environment. We're doing our systematic 10-degree scans, to make sure that we're covering the whole airspace. We're projecting where the aircraft's going to be, and we look in blind spots. And we try to angle the aircraft so we can see and expose our blind spots. The point I'm trying to make is that's see and avoid with manned aircraft. Now think about a small little drone the size of a red-tailed hawk. Think about the surroundings of that aircraft. If it's black, it's going to blend right in. It's going to be very difficult to see. Things we got to start thinking about. Another little human factors illustration here. Has this ever happened to you where I can't find the peanut butter? Where is it? As you start scanning that closet, maybe it's right in front of your face, but it is in there. Seeing an unlit stationary drone on a clutter background can be like trying to see an unlit stationary jar of peanut butter in your pantry, just like this picture here. Okay. Another perspective is we talked about, we have remote pilot operators on the ground looking up. There's some amount of contrast with a manned aircraft. Usually the first detector is going to be the noise that you're hearing. All right, something's coming. And then all of a sudden, if you're lucky, you will see it. But there's a lot of factors that can distort that. Obstructions, weather, you name it. There's many different elements that can reduce your ability to see a manned aircraft as a remote pilot. So we got to think about, what are we doing to increase the safety in our operations? How are we minimizing the risk based on our unique environment? Am I just worried about power lines and trees, or am I going to start thinking about, I have a zero vantage point, so if a aircraft overflies this area, I'm going to have zero time to react? These are things we got to start asking ourselves. So the human eye and detection of objects. Detection of objects while airborne depends on 6 conditions. Image size, so the portion and the visual field of the object, the luminance, the degree of brightness, the contrast, difference between the object and its background, color, shape, adaptation, the degree to which your eyes adjust to surrounding illumination, motion, velocity of object and observer, and exposure time, the length of time the object is exposed to view. A lot of this comes into play if you had to fall under special waivers for nighttime flights before they've been accepted and integrated into our standard Part 107 scope or regulations. But they had a lot of emphasis on illusions and the physiology of the eyeball. How does your eyeball work? How detectable is your drone to another aircraft pilot, measured against those criteria that I just mentioned? So inherent limitations of see and avoid expose most diligent pilots to the threat of a mid-air collision with an unseen aircraft. The limitations include, but are not limited to, human limitations, environmental conditions, aircraft blind spots, operational distractions. Mid-air collision pamphlets are available on the FAA FAST Team website. Division of flight: the most advanced piece of flight equipment in any aircraft is the human eye. And since the #1 cause of mid-air is the failure to adhere to see and avoid concept, efficient use of the visual techniques are essential. All right. This is our bread and butter right here in aviation, our eyeballs. Okay. We have Class 1, Class 2, Class 3 medicals, where we have FAA certified flight surgeons, or basically our FAA doctors who say we're in a condition safe to fly. There's a lot of emphasis on vision. Everything from, is it acceptable limits? Does it have to be corrected? But there's a reason for that. That's one of the last lines of defense we have with that Swiss cheese model. A lot of science, a lot of studying of the eyes in aviation. So I want to reference everybody to Advisory Circular 90-48 Echo, Table 1, for a breakdown of time it takes on average for a pilot to detect another aircraft. Really, we have a very small window of time to decide if a threat requires action, and then for us to physically think what to do, resort back to our procedures, and then actually take action. Relatively slow flying aircraft, manned aircraft at 100 knots ground speed, will cover approximately a half a mile in 12.5 seconds. So if you're distracted, you're losing that time frame. You're losing every valuable second. For some other task, that time and distance only increases. So we got to think about our priorities. Do we have a limited sight distance? If so, how are we going to minimize that? But also we got to think about, how quickly is an aircraft going to overfly us, and what type of response are we going to have as remote pilot operators to descend, to get out of the way, depending on the unique scenario. So how many seconds would a drone operator have to react to a low-lying aircraft? Think about it. You tell me. I'm sure we've all been in positions where we've been flying our aircraft or our unmanned aircraft systems here, and all of a sudden a plane, a helicopter, you name it, comes out of nowhere. And how many times do we say, oh yeah, that was fine, I knew it was coming, versus that thing came out of nowhere? It surprises us. It takes us by surprise. Okay. Think about line of sight, think about your operations area, and then think about these flying hazards. Picture one: you're in a field, you're in a forest, you really can't see over the tops of the trees. Aircraft can come flying over at any point. Even in a residential area, you're in a neighborhood with tall buildings. Think about, there's only so far I can see. I can see my drone, I'm maintaining visual line of sight with my drone, but all of a sudden, out of nowhere, a helicopter overflies. Or in picture number 3, even you're tunneled in there, or you're corridored in there, you're doing your flight operations, you can't see the right, you can't see the left, you're just playing fate at that point. So things we want to consider, we also want to consider our reaction times. So a little bit more about small drones. Drones, for those of you who are not fully familiar with what the rules and regulations are and how we operate our small aircraft here, or small drones. Drones are required to give way at all times to other aircraft. Drones are not allowed to transmit ADS-B out. Some rare exceptions exist for more so advanced systems. There's BB-loss waivers, type certifications. There's examples where that does exist, but not with the consumer grade drones a lot of our Part 107 operators are flying. Drone pilots are not allowed to transmit on aviation frequencies. There are some rare exceptions, however, that is no longer a thing. In the past, there was a thing. There was standard phraseology. I think there was Part 107 test questions about transmitting and understanding what you would say as a remote pilot on the frequency. No longer a thing. We refer to ground communications or picking up the phone. We have a pre-coordinated phone number. We'll call it the control tower if needed to communicate whatever we need. The reality is it became a little bit of a clutter for aviation frequencies, so they reduced it slightly. But there are examples where today some unmanned aircraft operations are allowed and permitted to talk directly to air traffic control or another entity over a radio. And then finally, small drones do not have detect and avoid systems. Drone pilot is responsible for ensuring the drone yields to the right of way of other aircraft. As we're seeing with our regulatory advancements in the industry, change is happening quickly. It's past overdue. It's, we're still growing and spooling up into it. But the reason is because we want to make sure that our aircraft, our unmanned aircraft systems are integrating as safely as possible into the national airspace system. When the drone pilot was located and interviewed in the collision cases in the US, they were consistent. There were some consistent practices by the drone pilots that have contributed to the collision, such as not watching the surrounding airspace, watching their screen showing the video feed. They were all shocked by the sudden appearance of a manned aircraft, especially since none of them thought a manned aircraft would even be near their operation. They all greatly overestimate their ability to see and avoid other aircraft in time. They become complacent, and that's one of the biggest killers in aviation is complacency. Whether it's checklist complacency, procedural complacency, that complacency leads to drift, where you are conditioned one way, and then over time, that condition wears off, and you start cutting corners, right? The drone pilot is responsible for yielding the right of way to other aircraft. We have 107.37, Part 107.37, or if operating as a public aircraft, 91.111. 107.31 basically pertains to visual line of sight requirements. There are other requirements that kind of feed into it. So being able to see the drone in the surrounding airspace with unaided vision other than their spectacles at all times during the flight, even if using a visual observer. So we have rules we follow. We have our own eyes, we have our own ears, we have our own agility and our own our own energies that we push into maintaining, scanning, ensuring that we're not going to collide with an airborne hazard. Okay, we need to think about those regulations. Why are they in there? And think about, are we following them? The rules are set for a reason. They're in there because, unfortunately, as we see in all sectors of international government and wherever, lessons learned dictate change. As proactive as we can, those decisions are backed with data. They're proven. They go through the whole public rulemaking process until they're signed into regulation. They come from somewhere for a reason, and a lot of times that reason has to do with that overall safety. So again, common findings with the collisions in the USA. Drone pilots mistakenly thought no other aircraft to be at or 400 feet AGL or below. Oh, I'm only at 400 feet. Manned aviators, they have to operate at a minimum of 500 feet, depending on their environment. Okay, so we think that 100-foot buffer makes us invincible. Not the case. Drone pilots overestimate their ability to react to another aircraft and underestimate the rate of closure of these aircraft. So think about two aircraft coming in at the same speed. That's double closure rate, even less time to react. So interviews with all these 7 collisions and all the interviews that followed, they revealed that all the drone pilots were either distracted, watching their screen, buried in that screen, not looking up, not maintaining SA, not watching the surrounding airspace, surprised by a sudden appearance of other aircraft, and didn't hear the approach of the other aircraft, right? And not necessarily a radio transmission, but the hum of that, the sound of that manned aircraft. Interviews reveal that all of these manned pilots didn't see the drone until it was too late. That's why understanding different perspectives, what does a manned pilot see? What does a remote operator see? We have to understand both sides of it to increase the safety. Common hazards encountered by drone pilots. So will the drone be flying above nearby structures and vegetation? Will your vision of the airspace down the horizon be limited by structures and vegetation? Will you be flying near an airport or helipad? Will you be performing other tasks while flying? Will you be operating conditions that may degrade the drone's detectability or conspicuously to another pilot? All right, we want to think about all the hazards and what do we do to mitigate these hazards. Hopefully, before you go flying, you check the weather, you check your NOTAMs, ensure there's no TFRs. You look into your site assessment where you're going to be operating. You do preliminary research. Again, depending on the risk associated, are you going to go in person? Are you going to think that if you're going to do a remote type of site assessment through Google Earth, is that safe? Is that preventing hazards? Possibly not. We want to make sure we want to validate our findings every single time we do a site assessment. What you see on Google Earth today may be completely different about the environment you show up in. That's why we want to have a systematic, regimented means for instilling safety and minimizing risk in every operation. So recognizing there is a rarely perfect site to operate from that gives maximum airspace vision, do a risk assessment and take the steps to reduce collision. Identify the gaps in your unobstructed vision down the horizon, plan the operation accordingly. If you're not familiar with an ORA, an operational risk assessment, there's many different types of safety management system tools, so you can instill the highest level of risk mitigation and hopefully avoidance into your operation. But we need to consider these processes, and we have to go through it very calculated. So for example, if you can't see beyond that building in front of you, at least down the horizon, well, think about it. There's an increased risk of undetected aircraft coming from that direction. Maybe you wanted to stay as close as you can to the top of the structure. Maybe you want to send a visual observer to the rooftop to watch in that direction. Just remember that 107.31 requires you to be able to see that airspace at all times during the flight, even if using VOs. So you're still responsible for seeing and avoiding. With manned pilots, they have training. They're trained to identify obstacles, fly as well above them. Sometimes they need to get closer to one might think, high voltage power lines for crews. For example, if you're flying within a few feet of wires to check the lines, unexpected to a remote pilot operator. Sometimes you may be operating in a rural area and you have ag pilots, agricultural pilots, dust croppers, often flying very low, being able to drop into that field. The lower your drone is to the ground, the less likely an encounter with a manned aircraft, because manned aircraft are generally safer the higher they go. Never let your guard down. It's not always the case. It is still your responsibility to see them and to avoid them. Studies do show that you need more time than you think to plan accordingly. We also talked about, through this presentation, lessons learned from data. Distracted flying is a major challenge with drone pilots, and we've seen this exact same type of scenario play out in this case study. It interferes with their ability to detect, decide, and act in time to get out of the way. Minimize these distractions by getting others to perform other functions such as your camera operator, communications coordinator, your drone pilot, visual observer, etc. You want to make sure you're covering all 360 degrees of your operation. Even if you think you have a known flow of traffic in your area, anything could change at any time. And a lot of these resources that I just mentioned feed into crew resource management, So discussion time. Thinking back to the Canadian example, in order to reduce or eliminate collision risk, what procedure or policy changes, if any, would you recommend to the department? Which hazards would you say were present but ignored by the drone operator? What procedure changes would you recommend for the drone pilot and why? What additional hazards are often present near heliports and airports? We have a bulleted points here about things we need to ask ourselves. What's the point of this presentation here? What are the takeaways? If you're asking yourselves these questions and you're able to build this into your workflow as a safe and responsible remote pilot, good on you, because you're going to be one step ahead of the curve. Think about how your decisions, how your unique operation is going to impact the NAS. Are you taking everything into account? Are you making the correct actions? So there really is no right answer other than, to question about what you do. And again, think about if you're in an emergency situation, what would you do? Okay. Dawn, I will allow you to open it up here briefly. Looks like we're at 1 hour here, so we are wrapping things up, but I'm going to let you open it up if anybody wants to throw any insights out regarding one of these bullets before we continue along here and close out the presentation. So if anybody would like to volunteer some points or things you've considered, maybe even share an answer to one of these questions that you routinely ask yourself, please raise your hand. All right, hearing none, we will move along. So if you suspect a collision with another aircraft, what exactly do you do? You want to notify the National Transportation Safety Board. The NTSB in the United States is our safety investigative board. They come in with unbiased, fact-finding protocols, and they come up and they create recommendations. If you need to report an accident or an incident to the NTSB, here is a phone number here. We have 2 of them. They also have NTSB guidance documentation for information about reportable UAS incidents, which we'll talk about in a second. Most, but not all, suspected drone strikes reported by manned pilots turn out to be something else, not a drone. All right. There will be reports that come out, hey, I almost hit a drone. There's all different types of anomalies that happen in the National Aerospace System. Maybe it was a bird. Maybe it was some type of physiological illusion that we thought we saw something, but it wasn't. It could be anything from reflections on windows, you name it. So just because there's a report that comes in, there's a drone, event that occurs, we want to be really calculated on validating that. One of the best ways to determine the impact of the NAS and how often these things are happening that are actually validated with unmanned aircraft systems is data. And that all is going to get pulled in through reporting. Then we can pull trend analyses and we can determine root causes and, hopefully make recommendations for regulatory change if there's a safety finding that can minimize some of these things, right? We look back, things I often, example I often reflect back onto are seatbelts. Seatbelts weren't required for a long time. Then they started becoming more and more commonplace. Then they became a requirement. Then we had laws, we had to wear a seatbelt. And if you think about that evolution, think about how many learning lessons there were. And the only way to create enough information and data to support the change was through reports, okay? If you do not suspect a collision with another aircraft or your drone experiences a serious incident that meets the NTSB criteria, you must report it to the NTSB as soon as possible. Not the FAA. If you need support from the FAA, by all means, they'll provide it. They'll forward you onto the NTSB, but NTSB has voluntary safety reporting systems that you can look into. Things you want to report to the NTSB are true flyaways, for example. Those are reportable. Flyaways where a drone basically executed the planned loss link procedure would not be reported. So your drone flies away, I can't get it back, it vanishes off into the horizon. That's a flyaway. That's a significant risk to the NAS. That would be reported to the NTSB. If you're flying your drone, you lose some connectivity, the failsafe kicks in, it returns to home, it lands. That is not something you report. Small multi-rotor UAS has a flyaway and it crashed into a tree, destroying the aircraft. Not necessarily an accident, though substantial damage to the aircraft and no injuries, but that's not necessarily a reportable accident. But say the operator is required to notify the NTSB of a flight control malfunction. That's one piece of criteria you would report to the NTSB. They may initiate an investigation. They may even report with a determination of probable cause. The point I'm trying to make here is understand the rules, understand what's considered reportable by NTSB and what's not. Those are slightly different than the FAA requirements. For example, we know if we have Accident resulting in death or significant injury, that's reportable to FAA. We have an accident with outside property damage greater than $500, reportable to the FAA. The NTSB has a different list of criteria. You need to be familiar with it. So 49 CFR 830.5, notification to NTSB. Here you can see the policy as it stands. Immediate notification. So the operator of any civil aircraft or public aircraft, including unmanned aircraft systems, shall immediately and by the most expeditious means available notify the nearest NTSB office when aircraft accident or any of the following listed serious incidents occur: flight control system malfunction or failure, inability of any required flight crew member to perform normal flight duties as a result to an injury or illness. Again, you have to look at the root cause. That's important data, because if it's affecting certain individuals, it can get studied and hopefully corrected. Failure to any internal turbine engine component that results in escape of debris, so not necessarily applicable for where we're at here, but an aircraft collision in flight. That's the key here. If your system, if your drone hits a manned aircraft, it's an NTSB event, it triggers the investigative process. There are protections for voluntary reporting that you got to consider. We also want to see 830.6 required reporting elements, 830.10 preservation of aircraft wreckage, mail, cargo, additional rules that follow under NTSB protocol. But if it is a reportable event to NTSB, you have to preserve the scene. You have to follow additional sets of rules a lot of people don't think of outside of FAA. So in conclusion, we're wrapping it up here. The message to drone pilots: expect manned aircraft to be everywhere and assume they won't see you. Don't let your guard down. Only go as high as you really need to go. When you're trying to get authorizations, don't grab all 400 feet AGL. Take what you need. The risks will be reduced, though they're not eliminated. The risk will be mitigated if you go lower altitude. So we, reduce the odds and chances of an interaction with a manned aircraft. Use anti-collision lights and make the drone color contrast with the background to be more detectable to other pilots. Not necessarily fully required anti-collision lights regarding the time of day you fly or night. However, another mitigation you can introduce. Minimize distractions. Remember, you're the pilot and you must see and avoid. Consider using a multi-person crew to separate your duties, like crew resource management. Task saturation, avoid it, delegate. This is your responsibility. You brief out the requirements before your flight. What are the roles? What are the emergency procedures? Do it every single time, because when you unexpectedly find yourself in an emergency situation, you're going to wish you did. So the probable cause and findings of the National Transportation Safety Board, it determines the probable causes of the incident. The failure of small UAS from a pilot to give way of the helicopter. What I'm getting into here is the actual the results of the investigation that happened on the case study here. So they determined the probable causes of this incident to be the failure of small UAS from a pilot to give way to the helicopter, resulting in in-flight collision. Contributing to an incident was the small UAS from a pilot's failure to assess and mitigate the risks of operations in close proximity to other aircraft. Also contributing to the incident was the lack of inclusion of the UAS operator as part of the aviation activity and risk mitigation. What I'm getting at here is there's a video that I cannot play based on the functionality here. I misspoke when I said that this was the overall presentation focus, the recap. This is more so a video that happened in Johnson Valley, California. That's the probable cause and the findings that I just described there. So I apologize for any confusion. Message drone pilots continued: follow your checklist every time. Conduct pre-flight mission risk assessment. Consider your likelihood and your severity. Introduce your mitigation, then reassess it. Train your visual observers. Place them where you need them. They can see the entire airspace and they can communicate you in a timely manner. Whether it's down to the horizon, at least a half a mile in all directions, use your team. It's important. And then call the System Operations Support Center for SGI waiver, authorization, and emergency. This is more so falling under like a Part 91 type of process. Many different resources out there, from the drone zone to the safety website that we recommend and that we live by here with the FAST team. But all different types of resources. That's going to be dronezone.faa.gov is the drone zone website. And we have FAAsafety.gov is the FAST team website. And then we have a message demand pilots. Wear eye protection. You never know what's going to go through your windshield. If you have eye protection, if you have sunglasses, if you want them rated for eye protection, again, anything helps. Expect drones to be everywhere. And assume they won't see you in time to get out of your way. Try to stay higher than 400 feet over tallest obstructions as long as possible. Mentor local flying organizations. Okay. Reach out, interact with UAS departments, reach out with training environments for UAS operators, collaborate, reach out. And it goes both ways too. And then finally, partner with the FAA safety team. So this happened in Chile, this picture here at 800 feet AGL. You can see some of the damage here. The drone weighed only 20 ounces and was less than 12 inches across. And we can see some of the aftermath of that situation. Broken windscreen and looks like possible injury. Some handy tools and references. Talked about a couple websites here. FAA.gov/UAS, even more resources. Airport helicopter, heliport data, emergency waivers authorizations. We have some circulars. There's an FAA public safety toolkit. I recommend if you want to screenshot this, all different types of things to help support you fly safe. We want to be mindful, be vigilant, and be safe. So there's some supplemental information I'm just going to expose to you so you have awareness. But for those of you who respond to negative reinforcement, don't be in a breaking news alert. The industry is growing significantly. We want to be the best stewards for safety, for expanding, developing, and influencing, really being the pioneers of UAS as it becomes more and more mainstream and more integrated. If this collision had happened in the US, these are the US regulations that would have potentially been violated by the drone pilot. So on Part 107, remote pilot and command, hazardous operation, visual line of sight, visual observer right away, airspace authorization, ops near airport, and then pre-flight familiarization. Under the Part 91, pilot in command, careless, reckless operation, pre-flight operating near other aircraft right away, compliance with air traffic control. In this specific example, this specific case study, the control tower wasn't open, but these were some of the findings that came out. So if the drone had caused injury to death or death to the manned aircraft flight crew, what's going to happen to myself as a remote pilot? Okay. The Department of Justice can bring criminal charges against any drone pilot who causes interference, disruption, or injury to occupants of manned aircraft. The penalties include fines, even jail time. So the decision to prosecute a drone pilot under this rule would be up to the Department of Justice. I leave off on this slide because we're not just flying toys. We're not flying off the shelf. This is fun. We're flying recognized aircraft, remote unmanned aircraft systems. We have our responsibility to infuse safety into the NAS. My family, they fly. Whether they're going to be on a commercial airliner, I have cousins who are private pilots. They have their own aircraft. We all interact with the NAS. If we're going to be interacting with the NAS as a drone pilot, think about the other people, right? So that is the presentation. I again, thank you for joining me. We can open this up for, I'm going to stop sharing here, stop presenting. We can open it up for any discussion if anybody has anything they want to add, any feedback or concerns. All right, if you want to raise your hand, there we go. Let's see, you got open up the view all. Roy, how's it going? Roy, you might need to unmute yourself, sir. All right, while we figure out opening up Roy, does anybody else want to, oh, there you go, Helen.
I'm already open. I was just trying to help Roy out. Sorry.
All right, let's, if we can, let's please give Roy another chance and we'll hear what Roy has to say. And while we're getting Roy some audio here, I'm going to just start wrapping things up here for the final closeout. I want to remind everybody remote ID is coming September 16th, 2023, requiring compliance with remote ID changes that have been introduced and are coming our way. Fly responsibly, make sure you have the appropriate equipment based on your type of aircraft. And if you need to fly in a FRIA, there are outs being established for you. Roy, I hear you. So just I'm going to ask you to be quiet for 1 second. I'll finish it out and then I'll give it to you, sir. Just 1 second. Bear with me, please. I also want to recommend and request all of us working with our FAST team reps, myself, if you want to go to the master website, faasafety.gov, you can look and see who your representatives are for your region. I know we have people from all over the Eastern Seaboard here and actually the US. So if you have issues, concerns, use us as peer advocates. They call us drone pros for a reason. We support the industry. We want to make sure that you're safe and that you're supporting the industry. Roy, I'll give you the floor, sir.
All righty. Well, it wasn't very intuitive, but Control, Shift, and M, I think, opens up my mic. It took me a while to find that. But in any event, Jason, I want to thank you for giving this this event, and I hope that there will be more. I have in the past, like a couple of years ago, gone on to the FAA site that has these fast, webinars and stuff like that. But it was very informative, I'll say, and I am looking forward to, I think, as you mentioned, you're going to plan on perhaps giving some additional webinar things. So keep us in mind when that comes up, okay? Thanks.
Thank you, Roy. I appreciate the feedback. Respect, sir. Anybody else have anything they'd like to comment, concerns, not necessarily about the presentation, but I accept all feedback if you want to email me, but more so about this event, how it played out, some of the findings, concerns you have as a remote operator, even a manned pilot, something you'd like to share. All right, seeing no hands raising, I want to thank all of you again for joining me tonight. Again, first kickoff, so breaking some of the ice here, figuring out and working through the platform for the delivery. It's only going to get smoother, and we'll keep adding things to make it even more engaging. So on behalf of Warren County Community College, UAS, I want to thank them for sponsoring, for what they do to help educate and help promote development in UAS in our industry with safe, trained, educated pilots. All the other academic institutions, if they're on here, respect to you too. Fully open to collaboration. Again, I volunteer with the FAA, so if there's support, questions, it doesn't just remain within our region here. I can help support you. I can help support your FAST team, drone pros, ensure that your answers and your needs are being met. As well, I want to thank all of you for your time tonight. Roy, I see you have one more question here, and then Dawn, I'm going to pass it over to you. So, Roy.
Yeah, one last thing. I think there were, according to what I saw on the bottom of the screen, it looked like there were 23 slides or something like that. Is there any way we could access these slides for future reference?
Sure. What I can do is I can go ahead and just got to clear it, make sure we're good there, and if so, we can send out a blast to you, Roy. Anybody else, if you like it, just feel free to email me. That way we can get you the presentation. We had 33 slides, and really the last 3 were just more so reference points. But
okay, thank you very much.
Jason, that was one of the questions that we had. Another question came in from Daniel Curry, and I'm sorry I didn't see it when he first posted it. For the previous slide about the Canadian report, in a situation that was urgent, could the pilot have a pocket-sized checklist for a quick look to prevent the collision, or the full checklist is absolutely essential?
So a couple things with that. All right. So we have different types of inspections. We have our pre-flight inspection. That's where you go through and you set up for the day, make sure your batteries, connectivity, do your safety risk management process, operational risk assessments happen. That's like the mission planning phase. So checklists are important there as you go down it. Memory joggers, you get your aircraft all prepared. Then you enter into the air. A couple 10 feet about, you do your controllability checks, you check all your controls, make sure you have lock on with your satellite. And again, this is dealing with a multi-rotor type of aircraft, which most people are more familiar with. That's your comprehensive checklist that starts it. Then we have in-flight emergency checklists. Those are things we want to have at the back of our mind. We want to be able to prepare and act. We don't want to just recite it. We don't want to just memorize it. We want to feel it, embrace it, because when things happen, they happen fast. We have to make sure that we're prepared. If you have a emergency checklist, it may have a couple quick little memory joggers, do this first, then that, then that. By all means, acceptable. But think about how much time do you have to recover? If we're thinking about a manned aircraft entering into your vicinity, emergency recovery is going to come down to pretty quick thinking, reactions and calculated decisions on those reactions. Okay, and then other types of checklists. You have through flight type of checklists where maybe it's not as comprehensive as your initial pre-flight checklist. Maybe you're doing multiple flights and throughout the day, and it's a little more abbreviated, but you're still covering the main factors for the safety. Hopefully that answers the question. But if it's an emergency, you want to be prepared, you want to be trained, and you want to, be calculated on what your next move would be.
That wraps it up for our questions on the board. Thank you.
All right. Well, everybody, thank you again. I appreciate your participation. We'll have different topics coming up. Hopefully you'll join us in the future if we're going to continue the series, which we do plan to. It's only going to get better. It's going to get more engaging, and I appreciate everything you do to help support the NAS, the industry, the integration, and the safety. So thank you, everybody.
Jason, thank you. Have a great night.